Projectile motion is a common application for a quadratic function. So the idea being is if you take anything and then you project it upwards, kick it upwards, shoot it upwards, it could be a rocket, it could be a ball, but it would still follow the same ideas for projectile motion. And that when you would start it and then you project it upwards, it would go up, but the velocity would start to decrease due to gravity, and then at some point it would hit its maximum peak, and then it would start going down, and then the velocity at this point would actually continue to increase until it hits most likely the ground or whatever else might be there. So the shape of it, when we look at it, does appear to be like a quadratic function, and then I have actually the general expression or function written over here. So the negative 16t squared, and I guess I should say what t and h are. So t is going to be your time. Typically it's written in terms of seconds. And the h of t, or the output of the function, is going to be your height. And in this case, it's going to be in terms of feet. So for the function that I've written, it does actually have to be feet per second, and that has a lot to do actually with this first term, the negative 16t squared. And that's actually acceleration due to gravity. So the units have to be feet per second in order for that to be the negative 16. For example, if I converted it to meters per second, I believe it's a negative 9.8 t squared. So it changes if I'm going to change the units. And the other part pretty much stays the same. So the v naught, or the v sub 0, is the initial velocity. And the h naught, or h sub 0, is the initial height of the object. So let's say, for example, we were dealing with an object, and let's see. So let's say we have an object that's thrown upwards with an initial velocity of 28 feet per second. So in that case, we would have v naught would equal 28 feet per second. And let's say the initial height is at 150 feet. And what that actually means, if I try to construct a graph out of this, the x is now our time, the y is now our height, and so what's happening here is that, let's say, if we start from a surface, then we're not actually starting at 0, but we can start 150 feet up, and the object is projected upwards, and at some point, due to gravity, it'll start to decrease in height until, let's say, it hits the ground, where the height would be 0. So we can actually write a quadratic function to express this object being projected upwards, 28 feet per second initial velocity and the height of 150 feet. So that's going to be h of t is equal to negative 16t squared plus, now we put the initial velocity, 28t, plus our initial height, which is 150. So now if I wanted to figure out the height at any time, just knowing that its initial velocity was 28 and the initial height 150, I could actually figure out the height. So I could plug in t is equal to 2 seconds or 2.5 seconds, and then I could figure out what the height would be at those particular times. And that would be just like finding different points on your graph. But one thing that's nice, though, in a piece that we're commonly look for is, let's say, the maximum height, which would be right here. And one thing I want you to note is that this is a parabola facing downwards, and that's actually because this 16 here is negative, and that reflects a downward facing parabola. So this point right here is actually the same thing as finding the vertex. So if we wanted to find the maximum height, it's a matter of finding the vertex. So since we have a quadratic function in general form, I'm going to use the formula that x is equal to negative b over 2a. So in this case, our b value is 28, so we have negative 28 over 2 times a, which is negative 16. So we get negative 28 divided by negative 32. And if we divide that, that gives us a positive 0.875. So essentially, since we found the x value, and I guess you could say for us that's our t, we found that it reaches the maximum height after 0.875 seconds, since it's been projected upwards. So then if we wanted to actually figure out, well, what maximum height is actually reached, we just have to plug that into our function. So we end up with h of 0.875, and we're going to plug it in. So I get negative 16 times 0.875 squared plus 28 times 0.875 plus 150. So once we calculate that, you should end up with about 162.25 feet. So the maximum height the object would reach would be the 162 feet, and we know that it would reach that maximum height after 0.875 seconds.